Hello and welcome to AI for Developers. I'm Chaitanya talking bot. Today's lesson is titled Transformer Architecture. Part 2. Encoding, Decoding, and the Full Picture. Last time, we learned that transformers are like superpowered text processors, especially good at understanding long sequences of words. The secret sauce? Self-attention. Instead of processing words one by one like old systems, self-attention allows the transformer to look at all words in a sentence at once. Understanding how each word relates to every other word. Think of it like reading an entire paragraph and getting the full context, not just one word at a time. This parallel processing is a game changer for speed and understanding. Now, let's see how this magical attention helps us build a complete system to actually do something useful, like translate or generate text. Imagine you give a transformer a sentence in a language it needs to understand. Say, "I love programming." The first major part of the transformer, called the encoder, takes this sentence. Its job is to read and deeply understand this input. Think of the encoder as a brilliant summary writer. It processes each word, but critically, it uses self-attention to figure out the asterisk meaning and context of "I love" and programming within that specific sentence. It doesn't output words. Instead, it creates a rich, numerical understanding or representation for each word that captures its context. From a developer's perspective, this means your raw input text is converted into a sophisticated set of numbers that the computer can really work with, embodying all the nuances of your sentence. The encoder isn't just one simple step. It's actually made up of multiple identical encoder blocks stacked on top of each other. Each block refines the understanding even further. Inside each block, you'll find 1. A multi-head self-attention layer. Remember this from last time? It's like having multiple perspectives to understand relationships. 2. A simple feed-forward network. A bit like a small, fully connected neural network that processes each word's representation independently after attention. By stacking these blocks, the transformer builds a progressively deeper and more abstract understanding of the input sentence. As a developer, you'll often see pre-trained models specify number of encoder layers. More layers generally mean a more profound understanding, but also more computational cost. Now that the encoder has deeply understood your input, it's time for the decoder to shine. The decoder's job is to take that understanding and generate a new sequence of words. Perhaps a translation or a continuation of your text. Think of the decoder as a creative writer. It doesn't just copy, it carefully crafts its output, word by word, based on the encoder's summary and what it has already written. For instance, if the encoder understood "I love programming," the decoder might start generating J for je, then Amy for love, and so on. Building a French translation. From a developer's standpoint, this is the part that produces the actual human-readable output you're looking for. Whether it's a chatbot's reply or a translated document, the decoder has a slightly more complex structure than the encoder, featuring 3 main parts per block. 1. Mask multi-head self-attention. This is crucial for generation. When the decoder is trying to predict the asterisk next word, it should only look at the words it has already generated. Masking prevents it from cheating by looking at future words. 2. Encoder-decoder attention. This is the bridge. This attention layer allows the decoder to look at and pay attention to the encoder's deep understanding of the asterisk input sentence. This is how the decoder knows what it's supposed to be translating or responding to. 3. A feed-forward network. As a developer, understanding masked attention helps explain why LLMs generate text sequentially. And encoder-decoder attention highlights how the model connects the input to the output, making coherent responses possible. Let's put it all together. You feed an input sentence into the encoder. The encoder, with its multiple layers of self-attention and feed-forward networks, processes and deeply understands that sentence, creating a rich numerical representation. This understanding is then passed to the decoder. The decoder then uses this understanding, via encoder-decoder attention, and its own mask self-attention, to generate words one by one, based on what it has already produced, to craft the output sequence. This entire collaboration, from input understanding to output generation, is what makes the transformer so powerful. As a developer, when you send a prompt to a large language model API, this entire complex interplay of encoder and decoder blocks is happening behind the scenes to give you an intelligent, contextualized response. After the decoder finishes its job, its final output is still a bunch of numbers representing the likelihood of different words. To turn this into actual, readable text, a final, linear layer, and softmax function are applied. Imagine the decoder saying, I think the next word has a 95% chance of being programming, 3% chance of being coding, and 2% chance of being eating. The system then typically picks the word with the highest probability. As a developer, this is why you might see parameters like temperature when interacting with models. It influences how bold the model is in picking words, allowing for more creative or more conservative outputs by adjusting these probabilities. The transformer architecture, with its innovative encoder-decoder design and pervasive use of self-attention, revolutionized AI. Its key advantages include 1. Parallel processing. Unlike older models, transformers can process entire sequences simultaneously, leading to much faster training and inference. 2. Long-range dependencies. Self-attention allows them to easily connect words that are far apart in a sentence, capturing much broader context. 3. State-of-the-art performance. This architecture underpins almost all modern large language models, LLMs, like ChatGPT, enabling unprecedented capabilities in translation, summarization, creative writing, and more. As a developer, understanding these foundational concepts unlocks the potential to integrate and build powerful applications using these cutting-edge AI models. Thanks for watching. If you found this helpful, make sure to subscribe to our channel and hit the like button.